Hey guys, Mr. Mackey here. Now yesterday I set you the challenge with a three-way Venn diagram to find out the probabilities of certain events occurring with these three films. Now before we find the probability and we do any of that, we need to complete this Venn diagram. Now as I said before, we start in the middle. 15 of these 125 people had seen all of these films. So now let's move on to this outer layer. Now this one represents those who have seen Endgame and Toy Story 4, which is 25. But we take away 15 from that because, well, that's in the middle. So that becomes 10 out of 125. That 120 people have seen Toy Story 4 and The Lion King. We take 15 from that. That becomes 5 over 125. It's a bit clearer. This one represents people who have seen Lion King and Avengers Endgame, which is 26. But we take 15 from that, so that becomes 11 over 125. So now go what goes in these three. So this represents the 43 people who have seen Endgame, but we take 10 from that 43 to get 33, 15 from that to become 18, and 11 from that to get 7 out of 125. What about this one? This represents the people who've seen The Lion King, that's 44. Take 11 from that, that's 33. Take 15 from that, that's 18. And 5 from that gets you 13 out of 125. Now what about this bubble? That represents the 40 people who've seen Toy Story 4. Take 10 from that, you get 30. Take 15 from that, you get 15. Take 5 from that, you get 10 out of 125. So what is the probability that if I was to choose someone, they have seen all of those films? Well, that is the 15 in the middle. That becomes 15 out of 125. That can be simplified. Anyone know what that is to? 3 out of 25. Can it be simplified any further? No. Now, what about just Avengers Endgame? So, these all represent conditions which have more than one film in it. That's just the one where it involves just Avengers Endgame. So the answer is 7 over 125. What about the probability that the film chosen was not Toy Story 4? Now this bubble here was completely Toy Story 4. Now if you said 7, add 11, add 13, which gets you a total of 31 over 125, you'd be wrong. There's one more group of people that we've not considered who have not seen Toy Story. And that's the people who have not seen any of the films. So we need to find that out. So there's 125 people in total. Let's find out the number of people who've not seen any of the films. 125 take away 7 is 118. Take away 10, 108. Take away 15, 93. Take away 11, 82. Take away 13, 69. 69 take away 5 is 64. Take away 10, 54. So out of all of them, 54 people out of 125 have not seen any of these films. And that needs to be included in our overall total. So the 7 plus the 11 plus the 13, which got us 31, add our 54. So the actual answer is 85 over 125, which can be simplified to 17 over 25. Complicated one, that. But it helps us find out the answer to this one, the probability that none of the person saw none of these films. It's just 54 over 125. Now we're going to be moving away from Venn diagrams today. We're going to be moving on to for the final lesson on Probability Week. We're going to be looking at tree diagrams. Now, tree diagrams are quite special because these focus on events that do not have association with each other. Let me give you an example. Unlike Venn diagrams, me and my mum had some events that were linked to each other because we had 3 films that were on both our lists. Whereas tree diagrams, the events that we're looking at will have no influence, but we're still looking at them if they happened. Let me give you an example. I have in my hand a dice and a coin. I roll my dice and I toss this coin. What is the probability that when I toss this coin, I get a heads, and then when I roll the dice, I get an even number? So, this is when a tree diagram will be needed, because we're looking at two events that won't influence each other. So if I toss the coin, this won't influence the number my dice rolls. So this is how our tree diagram will look. Now we're going to start off with the tossing of the coin, because that's what I did first. So what we do is we draw two lines like this. Now I'm going to put an H here and a T here. The reason why is because the H represents me getting a heads and the tails represents me getting a tails. So what we're doing is we're creating two different pathways, because that's the events that could happen if you go one way or another. I'm not making a one direction reference. So the probability that you get heads in this is a half. And the probability that you get tails in this is also a half. So what about the rolling of the dice? How does that get put onto this tree diagram? Well, you'd have to draw two more pathways, because you could either go an odd number or an even number. So I'm going to extend it from here to here. I'm going to put a 0, an O up there, not 0, for odd, and I'm going to put an E there for even. Now, what's the probability that I get an odd number when I roll this dice? That's right, it's also a half. And then it's the same for even. And then I have to do the exact same thing for this side for tails. I draw two lines, O, E, and I write the probabilities a half and a half. So what is the probability that when I roll the dice, I get an odd number and a heads? So, start here. The probability that you get heads is a half, and then the probability you get an odd number is also half, so you just multiply the two probabilities together, and that will get you 1/4. What about if I wanted to find the probability of me rolling an even number? Now, even though I'm just focusing on one of these two events from occurring, you still have to pay attention to the tossing of the coin part, because that's still happening. There's still events that are going to be occurring. It's just not featured in the question. So, the first chance I have of rolling an even number is when I toss the coin and I get heads. So that's a half times a half, which gets you a quarter. The other chance I have of rolling an even, of getting an even number, is if I get a tails and then I roll an even number. So that's a half times a half, also equaling a quarter. So what do I do with these two probabilities that I've just worked out? You add them together. So what's a quarter? Add a quarter. That's right, it's a half. So the probability that I would roll an even number, 1/2. Now here's one where a tree diagram will also be needed. I have a bowl with a bunch of beads in it. 5 of those beads are blue, 7 of those beads are red. I draw a bead out, look at the colour, put it back in the bowl. I draw another bead out, look at the colour, put it back in the bowl, because that's what lockdown has done to me. What is the probability that I would draw 2 beads of the same colour? Now we're going to draw a tree diagram for this. So let's start off here. And the first ones, we have an R for red and a B for blue. What's the probability that you draw a red bead? Well, there's 12 in total, 7 at 5, and there's 7 that are red, so the probability is 7/12. What about a blue bead? Well, there's 12 in total, you do 5/12. Now, that's the first event. That's the first bead that I drew. So now this is the second. You draw 2 more lines, you put an R here for red, and you put a B here for blue. What's the probability that I draw a red bead? Well, remember when I said I put the bead back in, that means I put the bead back, there's still 12 beads in there. So the probability that you draw a red bead again is 7 over 12. What about a blue bead? Well, same applies. 5 over 12. But we still need to draw this line. So da-da-da-da, da-da-da-da. This little theme tune, hope you enjoy. R, which is 7 over 12. And B, which is 5 over 12. So what is the probability that I was to draw two beads of the same colour? Not specifically two red, not specifically two blue, but two beads of the same colour. So let's focus on the red first. We do 7/12 times 7/12. That gets you 49 over 144. Now let's focus on the two blue beads. 5 over 12 times 5 over 12. That gets you 25 over 144. What do? We add them together. So let's add 49 over 144 plus 25 over 144. That will get you 74 over 144. Now, can this be simplified? Yes, it can. They both go into the 2 times table. So I'm just going to make a bit of space. I'm going to move this. Whoops, I dropped my black pen. This is how exciting this is. We're going to move this all the way up here. That becomes 37 over 72. Can it be simplified any more? No, because 37 is a prime number. And that is the probability that you draw two beads of the same colour. 37 over 72. Let's try another one. Let's do another bead problem. I have 7 red beads and 5 blue beads. I take a bead out the bowl, look at it, but I do not put it back in the bowl. I then take another one out of the bowl and I look at it. What is the probability this time that I draw two beads of the same colour? Now, this is your challenge for today. I want you to find the probability that you draw two beads of the same colour, but also I want you to find the probability that one of the beads is... This is your challenge for today. I want you to find the probability that not only you draw two beads of the same colour, but also I want you to find the probability that the second bead you draw will be red. I'll give you about 5 seconds and then we'll get into it. Awesome. So, let's start by drawing our tree diagram. So, we have our R at the top, with the probability being 7 over 12. And then our B, we'll call that a B, 5 over 12. That bit's fine. Now this is when it gets a bit more complicated. Now most people would have put, well, it's 7 over 12 again, but it's not. Because when I said in my example, I drew a bead out, but I did not put it back in the bowl, which means there's not only one less of a colour, there's one less bead in total. Now, if the first occasion I drew a red bead, that means there's 6 red beads left out of a total of 11. So the probability is 6 out of 11. Now, what about the blue beads? Well, if I didn't draw a red bead out the first time, there's still 5, but it's out of 11. What about down to this one? Well, if I drew a bead out the first time that was blue, that means there's 4 left out of a total of 11. And in the reds, well, I didn't draw a red one out, so that would still be 7 out of 11. So the first question is, what's the probability that I drew two beads of the same colour? So what I do is I first multiply my 7 over 12 by 6 over 11. Anyone know what that is? That is 42 over, anyone want to hazard a guess? 132. I'll simplify it in a minute because we still got to do these ones and I want to keep track. And then if we draw two beads of the same colour, we multiply 5 over 12 by 4 over 11. That would become 20 over 132. That simplifies to 62 over 132. That can be simplified, however, so the actual probability is 31 over 66. That can't be simplified any further because 31 is a prime number. So that's the first question. That's the probability that you draw two beads of the same colour given this circumstance. So let's now focus on the second question, the probability that the second bead I draw will be red. So we've obviously got the first one up here. If the first one's red, the second one's red. That probability, we had it written down earlier, 42 over 132. Now the second one will be different because we draw a blue bead first and then a red bead. So we multiply those two together and that will get you 35 over 132, totaling 77 over 132. Now this can be simplified. Anyone know what it becomes? It becomes 7 over 12. And that's the probability that the second bead you draw will be red. 7 over 12. And that's the end of probability week. We have finished probability. We will come back to probability in the future because there's a lot more to go over. But for now, we're going to move on and focus on shapes next week. Now, when I mean shapes, I'm going to be focusing on loads of things. Measuring, areas, perimeters, loads of things like that. We might need also to remember our knowledge of angles as well. How? Well, let's find out. Hope you've enjoyed probability week. Keep on looking at the odds and let's bring on shapes.